Good morning, everyone. Good morning. This is actually the last class for the season. So we're going to start off with our usual AI news you can use. And in a week where we've had a week and a half now since the Thanksgiving break, there's been so much news, but I just focused on two items here. First off was this article in the MIT Tech Review about an AI model trained on prison phone calls now looks for planned crimes by basically putting on calls you make from prison, not you personally, but someone, right? So what they've done, which I did not know, they've got this vast data set of prisoner phone calls and video calls. And they just did the obvious training, right? And built up this model, which can now, they claim, predict the planning of future crimes. This should sound familiar to you. We'll come back to these topics in a little bit. But the models crimes are being, quote, contemplated. That should remind you of this movie. If you haven't seen it, it's worth watching Minority Report, because it's all about the pre-crime, precog division trying to anticipate crimes before they happen. And the argument here is that they're trying to stop crime before it happens by monitoring every utterance. And so the Securus saying the tool is not focused on surveilling or targeting specific individuals, but identifying broad patterns and anomalies and unlawful behaviors. So this is the apotheosis of the surveillance society. So think about that. And like I say, we will return to this topic.
Dan, I have a question about Minority Report.
Yes.
Is it considered a good UI that naturally stuff in the air?
That is an excellent question. So Peter's question, rightfully so, is in the movie, Tom Cruise famously interacts by spatial movements with the UI for all of his advanced crime fighting interfaces. And it's terrible. But and the other thing about it looks great in the movie. And the other thing you have to realize is when you actually watch the movie, you realize that all of the displays are transparent because the camera display and is looking through the display at Tom Cruise. Awesome shot, but imagine using a transparent display. No. So we will return to this topic as well. What looks good in video, on film, and what might be creative in writing or novel may not be a great idea in reality. Good question. And to counterbalance that, I found this other article about this system called, which takes Roman texts, Latin texts, and allows you to do reconstruction. This is exactly the same as we learned in Peter's talking about large language models, about fill in the blank training. This is filling in the blank, except the texts are 2,000 years old. So you see here, we've got a fragment of I think this is a tombstone. And what the system is doing is filling in the missing parts, having been trained the extant stuff. Now, this is particularly interesting because people today still keep finding little fragments, what are sometimes called ostracons. So you get this little fragment with half of this text written on it, like it says, "Hi, honey, I need bread, eggs, and milk," right? Or whatever the grocery list of 2000 would be. So I found that particularly interesting. And you can see they trained on the EDR database Roma. So it's exactly the kind of stuff we've been seeing in large language models. I love this example. So today's lecture is going to be about 2/3 talking about building user interfaces, user experiences with various computer perception systems. And we're going to talk about what the different perceptual systems are and what you could do with them. And then in the middle, we'll have an example, we'll have a discussion about what one could do. And then we'll end at the very end with a kind of AMA conversation between Peter and I. We'll talk about how the course is going and what we think is going to happen next. So let's start with the obvious one. So there are lots and lots and lots of systems out there that take audio input use AI pattern matching in some form, and then generate the label of the piece of music or the spoken word or whatever. This is not speech recognition in a second. This is audio recognition. So there are multiples of these things, SoundHound, Shazam, you name it. You can even whistle your tune into some of the search engines. Like you can whistle a tune into Google, and it will tell you what that probably is. What's so interesting about it is that I want to show you a little video that I made of a system called TunePal. It's a specialty recognition engine for Irish session music. So it's the kind of music you would hear in a bar in Ireland, right? Irish session music. So this is produced by people at the University of Cork in Ireland, naturally. But let me just show it to you so you get an idea of how this works. This is a session. And I'm just standing there recording this session. And I'm wondering, what is this? Recorded it. What you see here is me playing back the video and capturing the audio on my phone and letting the recognizer run. Now, why is this harder than Shazam? Why is it different with Shazam? Because it's live performance. Shazam works with pre-recorded audio, already in the database. But this is a random set of people playing this tune. So I stop it. It's thinking, and it says TunePal thinks it's called Lafferty's with 53% confidence. And then if you hit the play button, playing the MIDI file. That's the MIDI performance of this, and it's even in the same key. Pretty damn amazing. And what's remarkable about this, I think, is that it's random performers, not necessarily playing in the key which it's performed in. They may be playing in a different key, they may be off by a little bit, half a tone up or down, and yet the recognizer works. You can go read that paper about how that actually works in practice, but there are mechanisms, there are AI tools for doing that kind of thing. Now, if you, for example, sing with your friends a particular song and try to get Gemini or audios like SoundHound to recognize it, it doesn't work very well. So it's still a challenge for AI systems. Now, as you know, speech reco works remarkably well. It has the offering of, 30 or 40 different languages. And so that performance is quite high. And the major accomplishment in the past couple of years has been to take speech reco from requiring high quality recordings into something where you can have a very noisy environment and it will just recognize Hungarian or Chinese or Ukrainian or whatever. One thing that it doesn't do really well right now is language switching. So remember we talked a little while ago about code switching? So you might say something like, I really want to espero para mi papá, right? Where you switch languages mid-sentence. That doesn't work so well yet. But language identification is becoming a pretty well-recognized and pretty functional bit of the system. So you can anticipate that's going to be in the future. Speech reco works remarkably well. And there's also, as we talked about a little bit, the quality of speech production and conversation is now much higher than it's been historically. So I'm going to show you a little clip of a video of the conversation model between Sesame and ChatGPT. Notice how natural the speech is. Pause for a second. Note a couple UI things here. First off, the speech bubble is vibrating as speech is happening. Now, a lot of these systems do exactly that same sort of thing. And you might think that it's doing some very kind of clever frequency analysis. It's just running off raw amplitude. It makes this bubble bigger or smaller. So it's very, very simple. You can write that piece of code in like 5 lines of code. Very easy. So it gives you, though, a visible feedback monitor so you know what's happening. Second thing is watch here for the endpoint detection. We talked about that a couple of weeks ago too. So endpoint detection here is pretty good. Listen. Notice the barge-in? These are all features you need in your conversational user interface. You need to have barge-in, you need to have endpoint detection, and so the endpoint detection here is around 100 milliseconds. It's quite good. I want to show you one more thing here. Did you notice that? It laughed. It interjected what are called paralinguistic utterances. These little like, that's a paralinguistic utterance. All it does, not just mindless verbiage, it often signals that the person who's speaking is having to think about it. So it indicates a certain amount of uncertainty or doubt, something like that. Anyway, I just wanted to show that to you because this is now the state of the art. It's quite good. Now, let's think about perception more broadly. We've got a bunch of senses, right? Smell is one of them. What I find so interesting about olfaction is it's really hard, really hard. We don't really fully understand how the sense of smell works. Fascinating paper here if you're into this. It turns out that we not only have these particular molecular shape sensors in our nose, in our nasal passages, but we also have a kind of physiological response that is in totality what you smell. So when you, for example, have smelling salts, that horrible ammonia feeling, that's part of the sense of smell. So this is basically showing you how you can build an AI model to build a sensor which then can parse whatever's coming through the airstream and tell you what it is it's smelling. There are also devices people are making that will synthesize a particular scent from a set of bases. Unfortunately, smell is more complicated than color. With color, you can just get by with a few colors and you can mix them and match them, and you know how that works in color theory. Smell theory is, there are several thousand base kinds of odors that you can detect. And now then you have to, for example, the scent of a banana muffin is banana and wheat and baking soda, et cetera, et cetera. It's more than just a simple thing, plus whatever compounds are generated in the baking process. Okay, so olfaction here is still kind of an open question. It's hard, but people are making progress. It's kind of cool. There are also other kinds of things to think about. Generally speaking, we're talking about perception, but I want to open your minds a little bit to think beyond basic perception. So when we think about vision, we typically think about a pixel map, a raster, which has, say, RGB values and so on. But cameras often can detect much more than we can see. So people have built cameras that can see into the infrared and see into the violet, and they call these hyperspectral cameras. Reality is some cameras already have this ability built into them. In fact, if you tear down, for example, your favorite video camera recorder, you will find in that usually a little IR filter that blocks out a bunch of excess IR. A couple of years ago, people found out that if you remove the IR filter and set it into night vision mode, it basically, Sony hated that, as you can imagine. But it was a thing you can do. But the point is that cameras actually see much more than we can perceive. And so if you now start to tinker with the response curves on different parts of the spectrum, you can get what are called hyperspectral images, which is what you're seeing here. So some, like you see in the picture with the face up there, can be used for medical diagnostic purposes. When you go to a dermatologist, they often have a UV shine on your skin. They can tell by augmenting their own perceptual system with hyperspectrum light illumination. The other thing you can do is by using very sensitive fast refresh IR, you can get something like this. I'll show you this little video here. So this is a baby, and what I want you to watch is to see how his face or her face is blinking. What you're seeing there is the pulse, heart rate monitoring. So by using IR, you can actually not only see the flushing and going of the skin, and yes, baby's heart beat about that speed, right? But you don't have to insert any sensors into the baby's skin. Think about what else one could detect if you had more kinds of capability. So there's a method, this is called color amplification in hyperspectral imaging.
Why is the rest of them?
That's a really great question. Part of it is that there is a blinking of the lights. So this is probably in a fluorescent room. So you're seeing that's a fluorescent because the phosphors go on and off. That's my guess. But basically what you're seeing here is color amplification in the infrared spectrum. Think about that for a moment. What other properties of perception can you amplify? So I don't have them here. Shoot, I don't have it here. There's a technique called motion amplification. We take a regular video, and every time a part of the image moves coherently, say with an image flow technique, you can amplify that motion so that, for example, the movement of a building in the wind becomes visible by amplifying the spatial deflection of the image. You look it up. There are great videos on YouTube on this. The deeper point is that there's a lot of perceptual data out there that we could do AI on. Think about what kinds of things you can do. So let's spend 2 minutes, 2 or 3 minutes talking with your neighbor. What other kinds of things could you think of? What other kind of perceptual signals might you imagine you could do with an AI augmentation? Let's minutes. So there's some hints.
Earthquake. Yeah. If you detect yeah. Well, I mean, is it specifically percentage? Yeah.
Okay, everybody, you've had a couple of minutes with this. I'm sure you've got at least 10 great ideas. What did your team come up with? Anybody want to volunteer? I know you came up with a really great idea. What's your idea? That would make a lot of sense, right? You walk into a crime scene, camera, 5-second delay, race out and grabs a full 3D image from that point of view. Maybe do that a few times so you get actually decent data. That's a wonderful idea. and then AI to label things. Some other team, good ideas? Come on, back row, what do you got? I'm looking at you. Yes. Body language.
Conversation that I'd be having with AI, but right now I can't pick up a lot. Conferring my brow, if I'm
Right. Right.
shifting my eyes, I think there's enough evidence-based research on behavioral that helps better inform how AI is.
Yeah. Nice. That's a really great idea. So the idea for the video recording was augment do some AI recognition of body language, eye furrowing, gesturing, looking away, looking side to side as though you're unsure of what's going on. You can imagine a lot. Anybody else have a great signal to analyze? No? Yes.
You're saying lie detection, like to detect lies.
Right. Anything more? Like
Detecting like getting pizza.
Right.
Minutely, or
Right.
you start perspiring.
Right.
It would be visible.
Yeah. Cool. Okay. So there's an interesting task using augmented perception capability. Very nice. Okay. Thank you. Thank you for that. Using one of the things I want you to think about perceptual AI stuff is using even traditional data in unusual and interesting ways. And so I for a couple of years ago, and it was so bizarre that I had to go read it in detail. And I did. I did the usual sort of validation verification steps. And apparently this is a real thing. So in this case, these folks in Germany figured out that they could use Google Earth images of cattle in farmland. And then they wrote a cow detector. And then they wrote a cow alignment axis detector. Millions of data points. And they found out that by and large, in Google Earth satellite photographs, you can see that these cattle align. So if you actually ride around in any sort of farmland, you'll see lots of cattle kind of lined up with each other. But the surprising thing here is that they seem to also align north-south. Like, really? Give me a break. Here's the deep point. You can use even traditional imagery. That's what the whole sort of Earth satellite, Earth imaging research tasks are all about. Peter's got an objection or comment. Yes. Yeah. Yeah. Yeah, that's a great question. I mean, the other thing is time of day effects are not accounted for here. So I read the paper and I read a few other papers, and they actually taken a lot of that stuff into account. So the image on the far left here shows when you aggregate the data over multiple times. So you get much less alignment. So there's also, as I said, lots of interesting Google Earth AI efforts going on right now, where you've got a planet worth of data, and if you aggregate it and build your recognizers and your classifiers, you can do all kinds of interesting stuff. Here's an interesting analysis of vegetation extraction of images of deserts. And so in my blog post, I think last year, I asked the question, could you write a crop circle detector? And the crop circles are not the UFO things. What I mean are the center pivot irrigation systems. And as an assignment for yourself, you might think about, how would I do that? It's straightforward to do. And so you can very easily jump into Google Earth AI and then write a center pivot irrigation system to see how much of previous desert is now irrigated with center pivot irrigation systems. Deep point. Perception is everywhere. We can now take advantage of it with AI methods. One of the AI methods of perception is for drone navigation. And I'm going to show you just a couple quick videos here. Here's one. This is a very consumer drone. Watch the interaction. Yeah, I know. Sorry. Point is, it locks onto your face and then it follows you around. And here's another video of the same kind of thing, except not his face, but his backside. The UI is simple as possible. Yeah, you can walk into the drone. Interesting point is that these are the kinds of capabilities that AI is just giving, and we can start to bake them into our products. So what I want you to think about is we've got these perceptual capabilities with AI tools. What kinds of possibilities does this open up for us as designers? What kind of responsibilities does it have for us? And the basic question you should leaving this class with is, how much does the user understanding matter when you design these systems? So having a drone that follows me around, I don't know much about it. I just think my mental model is it's got a little eye and it knows what I look like and it follows me around. The question will be when you get into extreme conditions, when a gust of wind blows, when you go into a, for example, a forbidden area, if you walk next to an airport, what will the drone do? Will it follow you unwittingly, blindly? No, I will tell you from experience, it will stop at the edge of the airport zone and will not follow you any farther. And if you walk out of its vision, it sits there until it runs out of battery. Point, AI systems have extreme behaviors that we need to think about and communicate to our users. What could possibly go wrong? Part of your job as an AI UX person who thinks about the HCI of these things is to anticipate the failure modes, anticipate the ways in which people have mental models of these, and the ways in which those are predictive or not. So I'll show you another couple interesting, you've probably seen versions of this already. Google Translate has a nice version of this. Is basically Google Translate with camera mode, translating into different languages. And you can do this pretty well. You can do image searches. You can do the speaking thing. We already talked about that. What's interesting to think about as we go forward in this class is to be able to track and understand how the advances in AI technology will become available to us as designers, as system builders, as product people. What kinds of things will we be able to do in the future? So just in the past 10 years, we've been able to do a lot of different kinds of things. Here, I'm not going to go into them all, but there's different kinds of ways of, for example, doing body pose matching. That's the bicyclist on the left. We're putting a grid of computed body poses based on what the vision system tells us, or being able to label these things. And of course, this is one I use all the time. When I'm in Chrome and I get emails from friends in Switzerland, this tells me I can easily translate that in the browser. This is a really important one because in Switzerland, you have to apply for health insurance. If you don't, they will throw you out of the country. So important email for me to read. And of course, you know about summaries. We've talked about that. We've also talked about style adoption. So this is using Grok, the XLLM, which has extended vision and capability. So you've probably read about this, being able to take the Studio Ghibli style and use it for anything. So this is, I just took one of my photos and did that. Or in the style of Van Gogh, or in the style of Botticelli. You didn't know I was around in the 14th century, did you? You get the idea. Image understanding and this kind of perceptual capability is being built in increasingly into different products. It's in our browsers, it's in our language models, it's in extended systems like Nano Banana and so on. So searching by image is now basically built into a Google browser. So you can click on something and say, what's this? In context. You don't have to actually go out and export that file and ask, what is that thing? So here, clicked on that particular image and it said, oh, it's this particular kind of Louis Vuitton product. You also have image record systems and object identification systems. Think about that. Remember we looked at image classifiers before? Remember that? We did the lab. We're going to do another lab in just a minute with image classifiers. But remember how they, right? So here's Google Lens. I can look at a photo and say, what is that? Ask for a translation or a location of a particular sign. A really handy one is to be able to scan the barcodes on the bottom of your new Wi-Fi device and have it configured automatically. When I first saw that, I was blown away. Some PM should get a Nobel Prize for that, just to avoid all the Wi-Fi config problems. And of course, when you're doing your Spanish homework, it's very nice to be able to look through these things and be able to get it not only translated, but also read aloud to you. Here's an interesting point. As we start to have more and more AI tools, it's just like having APIs that you can recombine in interesting new ways. Part of the cleverness of building AI systems going forward will be to what extent you can leverage your different parts together. Can I plug my OCR recognizer into my language translate module, into my speech generation module? Yes, you can. For you as students, you need to know what's possible. You need to understand the space of capabilities so you can start to think about recombinations. This is just Google Photos. Google Photos, like Apple Photos, like different photo products, has face identification built into it so that you can say, these people here, this is my son, this is my dog. And I will admit to you, dogs are really hard, but if it's your dog, you can get it right. We've also seen different kinds of products come out. We talked a couple of weeks ago about the Google Nest, okay? I'm sorry, the Google Clip. It was basically the little video device that's up. And then it's a little bit like having the device of the video cameras at home. It then clips out the most, quote, most interesting images, most interesting video segments. That didn't work. But that technology now lives in basically every home video automation system, finding the interesting bits where people are moving or when an animal walks through the field of view or something like that. We also talked a little bit about being able to erase people or objects from a scene. And so in the center panel there, you see the magic eraser function, where you can eliminate somebody from the background or change the depth of field just with an AI control. I honestly don't remember what this video is, so let's watch it together. No. We pause. Pause, I said. This is a system called userology. It is a very, very interesting thing. And normally at this point, I would give you a 45-minute lecture on the uses of AI to help you use your experience research. We don't have time for that today. Come back another time, I'll give you that lecture. But there are an increasing number of different systems that you use to help you do user experience research. So this particular one does a remote, unmoderated, avatar-driven interview. So what you're seeing in the upper right corner is a guy who is being interviewed by an AI avatar on the left-hand side. And so he knows that this is an AI system. Well, what the AI system has done is to say, hey, we're going to try out this new user interface for apartment stuff. And watch what happens. Watch the interaction between the person, the participant, and the AI system. So do you hear what happened? It asked the participant, why did you choose to skip that? Because he said, I'm going to skip this. And so it's doing an interview just like a human would do. So just like I would have to do and sit there and talk to this person for 30 minutes, watching them use my new prototype or my new product. Here's the upside of this. You can build a prototype. You can just vibe code it, get it working. Set up userologies, virtual avatars to do interviews, give it a script, which is really a list of goals, of things you want to find out, and let it schedule people. Now, what it does, it has a whole long list. Userology has a list of potential participants worldwide. It's got roughly 10,000 people it can call. These people, if they want to, they satisfy the screener, they will then jump into the AI avatar, which will then have a conversation with them, watching the demo. It will then transcribe all the conversations, all the actions, and make that a data set for you. So a friend of mine at an unnamed company did exactly this with a prototype they built. Launched this at 5 p.m. and came back the next morning at 9 and had 1,000 interviews, users, transcribed and coded, and they found all of the first blush sort of failure modes without having to spend any human time. I will caution you, this is not a replacement for real human interaction, real human observation. But this gets a lot of the first level stuff out of the way very, very quickly. So it would have, if we'd done this by hand, it would have taken months to do the same kind of thing. Get 1,000 interviews like this, it's a long, arduous process. To get then the list of the first 100 most common failure models, that's even longer. So this is a great first machete cut into the thicket of user experience research. So it's a really fantastic tool. So I'm just, like I said, that's another 45 minutes right in that topic right there. Going to the next thing, thinking about how AI can support people in day activities. So we've talked about vision, we've talked about all that. Here's another kind of thing, point and speak. So this is AI point and speak, explaining to a blind user what all the buttons on the microwave do. If they can't, or if they're illiterate and can't read it, they can look at that and it will tell them. So watch what they're, right? See what it's doing? Massively useful for accessibility reasons. Think about what you can do with AI perception, helping people who don't have the same level of perception or knowledge or skill that you do. So there's lots of interesting things you can do. So a classic problem for a lot of digital photography was getting the skin colors right for darker skinned people. This is a huge hassle at Google for a long time. And then Google, somebody who's smart at Google said, hey, we can fix the color response mechanisms. And they built an app called Real Tone that's now just built into the cameras. And so you can take photos like this and it comes out looking reasonable. Photography quality is still up to you, but now you can see what's going on. So here's an interesting transformation with and without Real Tone. Now you could say, I want the picture on the left, but that's an option now for you, where before it was not an option without a lot of photoshopping. So the key question for us as the HCI component is select. The answer is it's just an option, you turn it on or off. But the user interface question is, how do you gain access to it? What's the interface module that allows you to do that? And that's going to be true for a lot of AI products. How do you actually get to the control? We're going to give you the ability to modulate the entire function of a planet, but where's the control panel? How do I get to it? So, as I said, it's key to lots of different AI products. Obviously, doing things like advertising is a million kind of different applications you can do. with smart redoing of images or retargeting or changing size or language or whatever. It's also used a lot in gathering information about the world. So you might wonder, how does Google Maps get all this information about street addresses and locations? And the answer is they take photographs. This is what Google Street View is all about, is having that car drive all around and soaking up the images of the street addresses, right? And so we have to have really robust OCR for this kind of photography to work. We also need robust OCR to be able to read names and places and locations and so on. And of course, you knew this was coming, right? OCR for maps directions. So since Google's got all that great Street View imagery, what you can do is to say, here's the map's direction from point A to point B. Now, if you tip up your phone and get into AR mode, it will actually show you the picture and give you the direction you should be walking. So here is another example of image reco being used for guidance purposes. Now, when we heard from Andrew Chatham about cars in the world, the thing you have to remember is you cannot write a classifier for absolutely everything. There's the classic example of the old woman chasing a duck with her umbrella. I'm sorry, nobody wrote a classifier for that, right? And so there's all kinds of examples of really wacky things that happen. I was talking to a friend of mine who works at a computer company, and he reports they have exactly the same kind of problems. Like, who expected that they would say, you know, see a person on a unicycle with somebody on their shoulders? Like, I didn't expect that. But if you write a classifier that only does, you know, binary classifications like bicyclist, you just tossed out a unicyclist, let alone a unicyclist with someone on top. So there's a bunch of image tools. If anybody's interested in building something like this using the cloud machine learning systems, we still have access to some cloud computing credits. Email me, I will connect you up and we can actually do it. So understanding for AI products, like obviously for cancer detection stuff, there's at least one group that's doing some kind of radiography and AI system. Who's doing that in the final project? Anybody? You guys. I'm looking forward to your talk. So an interesting problem for for your talk and for a lot of the medical image analysis stuff is that it doesn't necessarily fall into a neat, you've got this disease, you don't. You have to somehow communicate the level of certainty that you've got. So here is a complex picture, radiograph of a kid's foot showing broken, and you don't ask how this happened. It's not good. In any case, we have to figure out to what degree this actual pathology and indicate that to the reader. And an interesting problem is that, you know, people are not always the same. You can't just look at an x-ray. You actually have to know the backstory for the x-ray. Is this a child? Is this an adult? Is it male? Is it female? Is it, does it have rheumatoid arthritis? You need to know all this additional information in order for these kinds of things to be accurate. So communicating and being able to build in the interpretability. Remember Bean Kim's talk? You need to be able to make this data interpretable to the user. And as I said, think outside the box. There's more to image understanding than just classification. So there's a lot going on these days in what are called world models. And a lot of that world model building uses things like Street View or 3D reconstruction or the crime scene capture tool, right? That's exactly another example of this. So we've got applications like that. While you stitch together, for example, in the photo scan application, stitch together multiple images together and then fix the seams so you have a nice coherent picture. And we've talked about before, Remember the classifier where you put in an image and it tells you what it is? It's a cat or a dog? Or what is that? If you don't have a class for the object you're identifying, you're kind of in trouble. That's 50% dog. So what we end up doing is building classification libraries, basically things that it can be or not be. So here are a few pictures where the upper left corner mite, and that's clearly a mite, but it's clearly not a starfish, even though it's kind of got a spiky appearance. Mushrooms down there, same kind of thing. These are what classifiers do. So we're trying to figure out how to label these things. And once you've got that, then we can start to apply these recognizers in interesting new ways. Just as we have recognizers that can look at Earth imagery and do longitudinal study, longitudinal analysis of desertification, for example, we can do something here with gender identity. So here's interesting analysis that was done over a bunch of video. Oh, and no audio? I guess there's no audio. We'll just watch the labels here. So these are the classifiers that are video in real time. So doing gender identification, whether or not they're speaking. And what the result you can do with data like that is create charts like the one on the right-hand side, where you can look at the total number of female characters and the number of male characters and the amount of time each does speaking in film or video. All of a sudden now, this becomes a possible data source for you. And you can read those charts as well as I can. It's a huge difference. You can also use this, as we've discussed before, for image retrieval. So you take a query like this and not only label it and classify it, but also start to find nearby images, images that are semantically related. This is what classical image search does for you. Like that. Image captioning is basically image classification and then pulling it up and then combining the labels to provide a semantic description of what you're seeing. And if you've tried this in any of the big AI systems recently, it's getting pretty good. It's not always 100% right, but it's getting pretty good. So here's an example of that. You can take an image like that and say, what kind of drink is this? Or what kind of book is this? And where do I buy it? And the problem is if you take a picture like this, so here I am somewhere in downtown Rome, and I say, label this, it's going to give me these boxes as labels of recognized objects. Now, what else is in that image? There's a lot of stuff in that image, right? So what I'd like you to do for the next 5 minutes, say, is go to this application, okay? Jump to this application and try to need a picture that you've got. You can take a picture if you want it. You're on your phone, take a picture here and see how well the classifiers work. Okay, everybody got this? What I want to find out from you in 4 minutes, 30 seconds is what worked and what didn't work. Any surprises? Go. The QR code works for everybody, right? And I'm sorry about all the bit.ly interstitial things. Deeply annoying. So basically, you're going to try the API, upload your image, and you can just upload it from your photo library. Along with you. Be sure you click the "I am not a robot" button, otherwise you'll sit there a long time. Are people getting it to work?
Yeah.
So is it working for people?
Yeah.
Yeah? What's not working for you? Anything? Yeah.
I tried like a stuffed animal and it was not able to get the right animal.
It got some other stuffed animal?
It went teddy bear instead of.
Oh, I see. So more generic then. Okay. It didn't give you the stuffed platypus you wanted or something.
Yeah.
Right. Okay. Anybody else? Okay, that's a great example of a problem. Anybody else have a huge success or a huge failure? Yeah.
Like a picture, maybe to tell a picture, and then like that is the moon and then a bunch of other things that like we got white, black, like night,
Right.
so let's go with it.
Excellent. Okay, so it actually did a pretty good job.
Pretty good.
And so the sample here giving it a picture of the moon, and it knew not only was it the moon, but it was a picture of the moon. So that's pretty sophisticated. So when we think about user experience of object identification, you've got, say, Microsoft Bing, you can, give it a picture like this, you select the image, and the interface here is pretty straightforward. I have to admit, this is better than the Google one. And so Google and Bing have been going back and forth, upping the status of this user interface. By the time you get here, it's not bad. However, notice the UI here. The top row on the right is all ads. Those pictures have almost nothing to do with the actual image that we're trying to identify. So it's a choice that you get to make when you're designing the user experience. Do you need to make money? If so, how can you communicate that? Because here it says, a little upper corner there, it says, well, what kind of flower is this? If you scroll down a little bit, you can actually get to a reasonable identification. It's a prairie mallow. And it'd be handy if the things it was selling you were prairie mallows, but whatever. So here's an interesting question for you. When you're using this tool, are you trying to identify the object or find similar pictures? Those are very different things. Historically, Google used to only do similar images. And there was a big shift a couple of years ago where it started running Google Lens on the image and trying to identify it, saying this is a prairie mallow flower, not this is more pictures of pink flowers that are sort of daisy-like. So there was a big shift there, and people were pretty confused for a while until they put a split here between the identification and the similar images. So you see here on the right-hand side, that's the Google image identification UI, where you image similar identifiable images, then images of the prairie mallow of the thing itself, and then the very last one is visual matches. So 3 different functions, one UI. So it does a pretty good job here. In this case, it shows you that it's this particular kind of mallow flower. And if you walk around campus, not this time of year, but in the springtime, you'll see these. Now, interesting question here as UX designers, what do you want, what do you anticipate that your users will do with this? So if you look in the upper right corner of the right image, there is a button there. What does that button do? I honestly don't know. So I clicked on it because I wanted to find out. It saves it to saved images. Where are my saved images? I'm on my laptop. It's not on, and I will tell you, it doesn't put it on my laptop. It puts it into a book list. I don't know what bookmarks are. See the problem? You can have this affordance, but unless you communicate what it does, you're not helping the situation. But this is all by way of saying that the UX of AI systems is really hard. It's still going to be hard for a while. So here's a real problem I had last week. I was using my phone and it pops up. So this is Google Mail. I'm trying to send Peter an email message. And it pops up right here, my work address. I don't want my work address there. Well, what's that called? So here's an interesting thing you can now do. So 4 years ago, that was a really hard problem. Now, what I did was I went to Gemini, I uploaded the image, and I said, what is this? Basically, you see the question in there? What app is this the UI of? And it gave me a very nice description. It said, here are the visual elements. It's Gmail running on iPhone or iOS. Great. Nice job. Now, the real question I had was, how do I make it a different email address? How do I get rid of the work email address? I will tell you this is the correct procedure. I went and did it. I fixed the problem. Because I didn't know what to call it. And previous incarnations of search, you had to know what's thing in order to be able to search for it. But now you can ask, what is this thing? What is this UI idiom? What is this UI widget that I'm looking at? And how do I work with it? So coming along with this is the whole repertoire of new interface possibilities that AI allows you to have. So you've probably seen this before. This is just a little video I made of a photograph, and I want to select that object, building in the middle. So I long press and watch. You see that? You see it's highlighting the thing? You see that? Awesome. However, I'll play this for you again, but this part right down here, see that? I want to select that. So yeah, I made the sticker, but I'm missing a part of it. Question for you, sophisticated users. How do you get that selected down there? See, it's just skipping right over it. I will tell you the answer. You have to export this image and modify it to draw a line around that additional portion, re-upload it, and then reselect it. Good luck. Took me 3 tries. There is currently no good UI idiom for extending the selection using a recognized outlined image like that. So once you get, so this is my contacts list. And what I'm trying to do here is show you how I can delete. So this is, I'm basically gone through the steps of the process here to delete my work email address. It's in my contacts list. So the thing to note here is that you live in an ecosystem where all of your apps talk together. So here my contacts manager talks to my email app on the phone and is providing my default email addresses. So in order to fix it, I ignore totally the Gmail app and go over to contacts and edit it there so that the data will be exported correctly. This is a harbinger of things to come. As we develop more and more of these kinds of tools, you're going to need to know how to figure out how they're wired together. So let me wrap up in the last couple of slides here. We're all about, today's lecture is all about how do we have perceptual capabilities and what can we do with them. Think about how to recombine these different pieces that we've got. Okay, got 3 more things here. We're going to talk about final presentations, and then we've got a coda where Peter and I will talk for a few minutes about the class, how it's gone for us. So presentations, 2 slides. You're going to be on camera on Thursday, or a week from Thursday, the 4th or the 11th, okay? Your presentation, your team will be for 5 minutes. So if your team has 5 people in it, you can either each talk for 1 minute or give one person the entire 5 minutes. But you don't get 10 minutes. You don't even get 6 minutes. You get 5 minutes. So I have a big hook and I will take you off stage. Okay. Big pro tip, practice. Practice out loud. You may think you can speak it in your head and time yourself and have the right timing. You are wrong. Does not work, right? So second big thing, when you give feedback to your peers, be kind, be helpful, and be actionable, because each of you will fill out a form like this for every talk that's given. That you will then get a piece of feedback. You will get a piece of feedback from every other student in the class. Right? We'll anonymize them. We ask your email here so we can figure out who's saying what and we can track it all back. But when we give you the feedback, it will all be anonymous. You won't know who said it. Right? So don't worry about that. I will strip out the ID. So there are only 2 questions. And so that last 2, what did you like best about this presentation and what? Okay, yes. 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 Yeah. So if you're remote, we'll give you a meeting video connection. So there are a couple, I know there are a couple of people who will not be here on the 11th. They should dial in, and we have at least 1 or 2 teams that have to present remotely. That's fine. But I will send out an email to everybody with the link for the meeting. Okay. Okay, good. So I've got a couple things here. But we were going to do, rather than having Peter give a formal presentation here, we're going to start with a kind of ask me anything thing. So I thought I would start by asking Peter.
Yeah.
Come on up, stand here with me. So Peter, yes, you made it.
Congratulations to Dan.
We've done this 5 times at Stanford. This is the 5th iteration of the class. What's changed for you over that amount of time, or since just last time?
Yeah.
What's changed?
I think it is different this time. And I feel like, so all 5 classes, we've kind of said, here's this technology that's really interesting and developing fast, and you're probably going to end up using it some in your career. But in past lectures, it felt like, this is just another one of the tools, right? That you'll also use a spreadsheet, or you'll use GitHub, or you'll learn how to fill out your OKRs and so on, and this will just be one more thing. Now it kind of feels like this is going to be something you're using every day. And this is going to change how you read and understand material, how you code, how you process images and videos, and everything else. So we knew things were changing and happening fast, but it really feels like this year is different than last year in that respect.
Yeah.
How about you?
Well, before I answer, we also want to allow you guys to ask questions too. So if you have something, I guess for me, the 7th time I've taught it, because I've taught it twice over in Zurich. And don't ask me to compare Zurich students with Stanford students. It's just, I'm not going to do it. But I agree with you. One of the things that is so interesting to me is the rate at which things change. So you're talking about how things do change, but it seems like it's getting faster. And I can't sort of believe that, right? Because we were working on Bard not that long ago at Google, which is sort of the very first LLM thing. It was only like 3 years ago. Was it 4 years ago? Something like that. And now it seems like there's a new model every couple of weeks. So now we've got ChatGPT XXX, whatever that is. And so just the rate of change has really surprised me. The side effect for us, we have to always modify the slides. We don't get much reuse out of it.
If we were teaching calculus,
Right.
you could use the same notes last year. But,
Right.
so I was at an unconference last weekend, and they had a session called Technological Jerk. And I said, that's an interesting title. I know some jerks in technology. But what they meant is there's technological velocity, and then the derivative of that is acceleration, and the derivative of that is jerk. And so the idea is that all of those are going up.
I completely agree with that. Question from you folks. Anything?
What's something that you taught in like the first iteration and second iteration of the class that would be really obvious today, or something that
I don't know about really obvious, but I think I mentioned this to you. I had this conversation with Dan Jurowski, who's a professor here in linguistics and computer science. And it used to be, so 5 years ago, I remember being at Google and you would hear a team pitch how they were going to do a product. And it would be, well, we need a little bit of natural language interface. It's not a natural language product, but it's got this little bit on the side. And they would say, oh, well, we're going to use this kind of model, or, you know, we only need a couple of regular expressions and that will do it. Or we'll use this kind of simple model. And there were all these tricks and there were trade-offs for when you should use one or another. And now it's just, obviously you'd use an LLM. What else would you use, right? Nothing else could come close to that. And so this like decades worth of technology and tools of the trade for how to build a product out of it, that's all gone now. We don't need to do that anymore. And that's a new change.
That's a good point. I would say something in that. The advice we give about prompting has changed a lot. Because you know, like the first class, we'd have to prompt and reprompt and reprompt and reprompt. And now you kind of get it in the first one or two. So that's the quality of the prompt interactions really changed. As well as a lot, like the imaging stuff that we just talked about. A lot of that's gotten a lot better.
Yeah.
Still don't believe the image results though.
And I guess it's a similar thing with the self-driving cars, right? So you tell us everything, but we can't start our own self-driving car company from what we know. But it is true that a few years ago, there was much more kind of these handwritten rules of, in this situation, the car should do that. And then it was like, and then there's a neural net to do kind of the vision processing. But now it's end-to-end neural nets. And so, you know, we saw that first for speech recognition and translation. And then over the years, now it's come.
Other questions? Tobias.
where do you guys each fall on the glass half full, glass half empty, like societal impacts of all of this?
So I'll answer that first because I have 4 more lectures on societal impacts. So I think it's a lot. In fact, I deleted a bunch of slides from today's lecture because it was going to run all about the effect of AI, people using AI on their critical reasoning skills. And there's been recently a really interesting study with N of 10,000 students. So it's pretty interesting. So I worry about that. I think there's going to be huge societal impacts. Come back for the next class. How would you answer that, Peter?
I guess I'm optimistic, but cautious, and that you know, anytime there's big changes, you have to worry about that. Anytime there's powerful technology in a world in which not every person is kind, period, and courteous, then you have to worry about people taking advantage of it with that technology, right? And so there's a lot of exploits that could be done. I guess I'm encouraged that it feels like we're really grappling with this right from the start. So we have other classes at Stanford, and you know, all the researchers are really interested in these things to an extent that I think we didn't have with other technologies, right? So
yeah, that's a good point.
150 years ago, or whenever it was, internal combustion engines started replacing steam, and we saw this is going to be great for technology, but nobody was saying, well, let's worry about pollution, let's worry about traffic, let's worry about traffic deaths and all these other problems that came decades later. And with AI, it feels like we're identifying those problems right from the start.
You know, there was equivalent kind of thing when the ballpoint pen was introduced. There was not a moral panic about students suddenly being able to write much faster because they don't have to dip their quill into ink every so often. So I think Peter's right. It's much more pervasive kind of change.
Has your experience observing this?
Yeah. Peter, what would you say to that? How has it affected your career motivations?
So, I guess I feel some responsibility as an elder in the field.
As you should.
Right. And, so I feel like, my time for the field forward has passed. And so now I can serve as a kind of a reflection on where things are and try to be a mentor to people to continue pushing the field forward in a good way.
Yeah. I think that's a great way to close off this segment because I feel exactly the same way, which is why we're here, actually. Yeah. All right. Great. Let me go on to the next segment here.
Okay.
Thanks, Peter. Around, and we'll be here on obviously the next 2 Thursdays. I wanted to bring up a couple closing thoughts. You should recognize this. This is the statue of Prometheus, the bringer of fire, the Greek titan that brought fire and knowledge to mankind. Now, the other part of the story you may or may not remember is that the Greeks thought that Prometheus was chained to a rock for doing it because Zeus was chained to a rock and had an eagle come and eat his liver every day. It would miraculously regenerate and the eagle would come back the next day. So this is a really bad outcome. Why the liver? Because the Greeks thought that was the center of emotion and cognitive thought. So that's where, it's the worst thing that could happen to you. Versions of this story have Hercules coming and rescuing Prometheus, but that's not our point. My point here is that we are going through, basically, we have a new kind of technology, as we just pointed out, it's super pervasive and very, very much a part of what we're trying to do now, what we see going forward. And so I ran across this word called the torment nexus. And the torment nexus happens when a company takes a kind of a dystopian idea from speculative fiction and makes it real. So the idea is not to take bad ideas from fiction and make them real. That's a nexus torment, a torment nexus. So design fiction, if we go to the design class, we write these design fictions as a way to explore the ideas and figure out what's good and bad about them, right? So don't adopt the bad ideas. I mean, it seems obvious, but you see people all the time saying, oh, I read this in 1984, we could totally do this. Or we could do the Minority Report thing, and we could build those interfaces where people wave their hand. Don't do that, right? Now, I bring this up because there is this notion from dystopian science fiction about ultimate surveillance. And so this came out recently where Argentina is using AI to predict future crimes. Oh, wait, have we heard this before today? Yes, we have. So trying to predict future crimes is like the precognition people. And so we end up with this kind of neck, which is terrible, of universal surveillance. And you might remember the Minority Report. It's exactly that thing. You might also remember Clearview, which is the universal face recognition identification application. So if you're on the dystopian view, you now realize that every one of your faces is in the Clearview database. Okay? On my bike ride here, I live 4 miles that direction. On my bike ride here, 25 different cameras that I know about that could pick out me and identify me on the way here. That's just the ones I saw. I didn't count the number of Teslas that could do the same thing. I didn't count the number of Ring cameras on people's door fronts. See the problem? So be that as it may, what we've tried to give you here in this class is this overview of how humans work together. And so I gave you this little visualization of what we did. So the red stuff is all the design part. Now, there's some overlap between all these entries, but we talk a lot about how to design AI to give you self-driving cars or to give you effective mental models, robots that work, and so on. We also had a little bit of ethics and law. We had 2 lectures in ethics, but I think we talked about ethics a lot in this class. So it's basically going through everything. And also we talked about capabilities, because as we talked about today, understanding what's possible gives you the ability to design the next new thing, right? So I hoped in designing the class this way, what we've tried to do is give you a nice balanced 3-4 way different perspectives between the background you need to know, the capabilities that allow you to design going forward, design issues, and legal issues as well. For this class. So I want to leave you with the last video for this class. I'm going to skip around a little bit in this, which is, I think this is one of the best applications I've seen for speech reco and machine learning that I've seen in a long time. So this is the story of a former football player who now has ALS. And so I'm going to skip forward a little bit because that's the PM. And so what they're doing here is training the model to recognize his particular speech. They take samples of his speech and build a model. This is all the training phase. And now they're testing it. So the point here is that they're building not only a speech reco system for him, but his own voice in as a speech synth module. So they can recognize what he's saying and then use his own recorded voice model to generate speech out. Oops. Dang it. Back up just. So I'll let you watch the whole video yourself. But that's a magical moment. That's his 22-year-old voice, parents, telling himself and them through perception and through generation what would otherwise be unavailable to them, just impossible. So when you get a chance, watch the whole video. It's only 7 minutes long and it's really worth watching. So I want to end this class by saying, I hope that what you take away from this class is a lot of basic knowledge. So an understanding that we have agency, you have agency to affect the future, right? You can build the ultimate surveillance device, or you can help build something like Euphonia, that system that he was using. And so I hope the perspectives you gain from this class will allow you to make what I think are wise decisions to make us all have a better AI future. Build systems that can work, but also they should work. All right. Thank you very much. And we'll see you all on Thursday. Thanks for coming. Everybody got it? Oops.
Yeah.